Okay, let us consider this one. It's a double binary plane also, as we are going to see there. So there we have diagrams above show above, so you have this as you see there. Show below, above show mass of block A, B resting on smooth surface. Now the surfaces are smooth, so you don't expect anything like friction. Inclined at 30 degrees, inclined at 30 degrees. Strings attached to A and B are both connected to block C, with the strings making an angle of theta and alpha to the vertical, as you see here. A, B, and C have masses to M, M, and M respectively, and the system rests in equilibrium. Show that this is equal to this, and this is equal to this, hence find alpha and beta. So if they tell us that the system rests in equilibrium, it means that there is nothing like acceleration and the forces are equal. So if you have to go with this, because the strings are very smooth, we can start by resolving this. So this one downwards is going to give us 2m times gravity. Then to resolve it in this way, we have 2mg cos 30. Then this one, we're going to be having a resultant 1. And then this one, we shall be having 2mg sine 30 degrees. These things are different, so this one let us call it the tension T1 in this string, and also it's going to be the same in that string. So this is T1, so they are T1. So we are done with that. So this one is mass M also. So this one is going to be mg. I'm trying to make it so that I can ever use this space. That's why this one is above this part. It's there. So now, this one, we are going to solve it like this, mg. Then this will give us mg sine 30 degrees. This will be mg cos 30. Then this will be a reaction 2. Okay. So after doing that, now it means that now this one is having tension T2 in its string, the same which you are going to be having there. T2. Now instead we have these ones, then we are going to resolve them. So if I'm to resolve the first, I'm going to resolve this, going this side, and then coming this side like this. So meaning, because this is adjacent, this one, okay, so I know. Anyway, so this one here, based on this angle, this is adjacent, and this is opposite. So this one is going to be I don't know if people are able to see that. Anyway, I don't know. So it's that based on this one is going to be this one. I want to write it vertically like this, but I think, okay, when you base on this first T2, you see T2 shall move like that and like this. So this one being opposite, this will be T2, then opposite sine alpha. And then this will be, this vertical force here will be T2 cos alpha. I don't know if I am able to see that properly. Then this one, if I resolve this like this, going this, then I resolve it like this in that direction. So this will be its opposite, so it's going to be T1 sine theta, and then this one upwards, this one here is going to be the adjacent T1 cos theta. So if I try to resolve that order. Okay, so after doing that, then I start doing the work. So I come to 2m mass We don't have friction, so resultants are not that important. So you see that now the direction, the particle is going to be in equilibrium, but because this one is a bit, when you base on this one is a bit, because this one is bigger than this, we would expect the acceleration to be in that direction. So now, if I resolve in that direction, like this, because the body is in equilibrium, it means that now this body is balanced with that. So meaning our T1 is going to be equal to this one, mv. Oh, this is 2 mv. So this is 2 mg sine 30 degrees. So this is 2 mg sine 30 degrees. I know sine 30, so our T1 will be 2 mg sine 30 is a half. It's going to minus our T1 is going to be mg for this equation 1. So now when we come to M mass, we have to certain result because all surfaces are smooth. So M mass, if we consider force along the plane like this, because there is no acceleration, it means that this is equal to this. So T2 will be equal to mg sine 30 degrees. Our T2 will be mg into a half, so our T2 will be a half mg on this equation 2. Let us turn to this one, the M mass. So this one we are going to resolve it vertical and horizontal. So if I'm to resolve it upwards, so what is taking it as upwards, we have first of all this one, T1 cos theta, and what else? And this one plus T2 cos alpha. It's because it's the body is in equilibrium, it will be able to be mg. But now from here, we know what this is, we know what this is. So M1, so this one is M1, mg cos theta plus a half mg cos alpha equaling to mg. Divide through by mg, so this will go, and this will go. So we shall have cos theta plus a half cos alpha equaling to 1. Multiply through by 2. We have now multiplying through by 2. Yeah, I think we did that anyway. Let us multiply through by 2. Or you can see multiply by 2 gets 2 cos theta plus cos alpha equaling to 1. So if we interchange them, we get cos alpha plus 2 cos theta equaling to, sorry, this is 2. Multiply here by 2, here by 2 by 2 equaling to 2. And I think that proof is done. Then let us prove the other one, part A. Part A, if you resolve in this direction, like that, we are in that direction, it means that now this part, it means that this one is going to be equal to that. So T1, T2 sine alpha will be equal to T1 sine theta. So if that is the case, but we have T2 as a half mg sine alpha equaling to mg sine theta. Divide through by this mg, and then we multiply the sine, a half sine alpha equaling to sine theta. We bring this beside, our sine alpha will be equal to 2 sine theta. And also that one, I think is done. Hence, find alpha and theta. So let us do the hence part. So what are you going to do in the hence part? Now, in the hence part, you see from here, I want them to be the same. Here and if I use this, I want all of them to be the same. So that now, if I square both sides and I make one the subject here and I make this the subject, I can be able to substitute in this equation. So from sine alpha equaling to sine theta, if I square both sides like this, I'll be having sine squared alpha equaling 4 sine squared theta. Now from here, we can make, you know that this one is going to be 1 minus cos squared alpha will be equal to 4 sine squared theta. Now what I don't want this, I want it in terms of theta. So I make this from here, I can make that the subject. Okay, so there, but our cos alpha is equaling to, when I take this side, 2 minus 2 cos theta, like that. So now, if I substitute in there, I'll be having 1 minus, now 2 minus 2 cos theta, the whole square, equaling to, now some bring now with the answer. Now still, because this I'm going to be having cos, so I also remove this. So I'm going to be having 4 into now 1 minus cos squared theta. So now my equation is having one thing out. Okay, so now we can expand this. I'll be having 1 minus 4 minus 8, this and this then by 2 cos theta, then plus 4 cos squared theta equaling to 4 minus 4 cos squared theta using calculus of trigonometry. Okay, so from there I can open brackets, then I simplify. So this one is going to be, I open brackets, I'll be having now 1 minus 4, now plus 8 cos theta minus 4 cos squared theta equaling to, after opening brackets here, equaling to 4 minus what? Minus 4 cos squared theta. So that this one is going to rest. And then this is going to be negative 3. When I take it this side, I have from here 8 cos theta equaling to, this is negative 3, take this side, comes 7. And so our theta will be cos inverse of 7 over 8. And so my theta, from there my theta is going to be, so I'm getting 28.96 degrees. If that's my theta, how can I get my n? There are many ways from here. So from, you can either get from here or from here, but I think this one will give us, here we shall reach earlier, or if we put it here, because we have what this is from here, and so our cos theta is 7 over 8. It's up to you, either use the angle or come and put this here and make it a subject and make cos a subject. It's up to you. Or you use this and you put already your theta because you have your theta already. Then it's up to you. So from here, let me use this one, sine alpha equaling to 2 sine theta. So my sine alpha will be 2 sine theta 28.96. So my alpha will be sine inverse of 2 sine into 28.96. And so my alpha there is going to be I'm getting 75.56 degrees. That would be the answer. So basically that's what we have, and that's why we prove that number there. I wish you well.